let's talk about Rust then. Where we left off last time was sort of the crate and module system. And one of the reasons I wanted to get to the crate and module system this week is because those exorcism exercises ask you to build library crates effectively. Weirdly, you don't do programs, you actually do libraries, and then their driver actually, calls your library to do stuff, it runs its own tests. So the structure's a little different, and so I wanted to do it more detailed. We had you read chapter 8 in the first week, which is the sort of crates and modules chapter, so that you can get started understanding how that works. I want to go through that in detail again today, and sort of give you some idea of how Rust works at the level of programs that don't fit in a single file, programs that try to provide a service rather, libraries rather than executable programs. All that makes sense? So let's just dive in. And again, please don't hesitate to interrupt and ask questions. That's what we're here for. Make comments. So Rust has a module system. That sounds like, well, duh. But honestly, the number of languages that don't really have a module system is surprising in the current year. C++ arguably does not. I don't know, I haven't looked at C++ 20 yet, but C++ arguably does not have a module system. Instead, it has include files, which is straight textual inclusion. Languages that do have module systems, they tend to be sort of namespacey variants of textual inclusion. Python's module system is like that. Standard ML has the best module system ever. It's awesome, but the Rust system is good as that. It's also way easier than that. So this is just a pretty standard namespace module system. One of the things that Rust and Haskell and a couple other things do that most languages don't is that it does intermodule type checking at compile time. Call code in a related module to make sure that types match. That turns out to be really important for designing good checkable APIs. So in general, and again, this is a generalization, we're building two kinds of things when we build modules in Rust. We're building crates and we're building modules. Oh, sorry. There are not two kinds of, you don't build two kinds of things. There are these two kinds of entities, and they're related, but they're not the same. And so I want to get that clear up front because it's a source of confusion a lot of times. A crate is an artifact. It's a library typically, or a binary. It's a thing that you actually build. A module is a unit of organization in your Rust program, right? So it turns out modules can't cross crate boundaries, no big surprise. So if I have a library, it may contain a whole bunch of modules in that crate, library crate, but those are local to that library crate. And this notion that things are local to crates, modules are local to crates, names are local to crates, is a really important idea in Rust, in the sense that if you don't understand it, you'll get really confused by the error messages you're getting. You'll get really confused about how to organize things. If you go to crates.io, you'll find the big repository of published crates. We've looked at this before. We looked at this earlier in the course, but this is the place where things come from. It's the equivalent of CPAN or Ruby Gems or Pip or whatever your favorite, Cabal or Stackage, depending on which religion you belong to in the Haskell community. It's a place where automatic build tools, in this case Cargo, can go grab libraries for you that have been published there. Crates.io as a website is actually pretty terrible. Crates.io is a modular repository. So the hardest question to answer, and I don't have a good answer for you with Crates.io, is how do you find the new crates? How do you find the crates that do what you want? Neither of these questions are very well answered. Honestly, the best answer is probably Google. Another thing to be really aware of with Crates.io is that there's no binaries being shipped around. this thing we call binary crate. If you download it from crates.io, it doesn't mean it downloads any binaries. It actually just downloads the source code. If you download a library, if Cargo downloads a library, it downloads the source code, and it compiles it on your machine. This Gen2-esque approach has some advantages. It also has some terrible disadvantages. Certainly people complain about the compile times. First compilation when you have downloaded 50 modules that all depend on each other and how you compile grind through chewing that out. But that's how it works. So a crate can either be, like I say, a program that can be installed, it can be a library that can be published. And there's this, Cargo has this thing where there's this cargo.toml, which is a required part of your Rust project, but it's not required to put very much in there. And in particular, sort of, Cargo has default places it looks for your stuff. If you have a file called source/lib.rs, it assumes that's the top level file of some library crate that you're trying to build as a library crate. If you have source/main.rs, it assumes you're trying to build a binary crate, an executable program, and it assumes that main.rs is the top level thing of that executable program. If you want to break your library into multiple modules, you can put a mod.rs in, and it will assume that's the sort of top level module organization for some Rust library crate. And those are all standard conventional names. You can override this all in cargo.toml by adding stuff in there if you don't like your organization for some reason. Obviously, I would recommend you don't without a really good reason, because people expect to see it that way. There's a bunch of other conventional directories in Cargo that are sort of outside the scope of this discussion, but I'll mention them anyway, because this is the only time we talk about Cargo. There's a tests directory into which you can put files, .rs files that are intended to be run by Cargo tests and contain tests. There's an examples directory, which works with Cargo run -- example, so that you can put little example programs in your library crate in some really convenient way, and they're, sort of automatically installed when you install that crate. There's, I think that's most of it. So the point is, it's worth reading some Cargo documentation or tutorials in the book or elsewhere to sort of understand what Cargo expects to have happen. That said, at the end of the day, defaults aside, the cargo.toml file, as you might expect, is the thing that tells the primary thing that tells Cargo what to do. And in particular, there's a dependencies section in your cargo.toml when it's created by Cargo init that's empty, but obviously you can stick library dependencies in there. That's a thing you can do. And so, if I want to have the foo crate, I can say foo equals 0.4 .star as a dependency, which means get version 0.4 something or other of the foo crate and make that a thing that my project will use. So crates.io, when it's compiling your thing, will download, Cargo, when it's compiling your thing, will download that file from crates.io and compile it so that the foo library is ready for you to load the units. If your thing isn't on crates.io, but it is on Git, you can specify a dependency on a Git repository as well from GitHub or GitLab, like this. That's a common thing to do if you want to hack up somebody's library a little bit, is you hit the fork button and then push your changes up to your fork of their repository and then point your cargo.toml at that. If you just have local source code that you want Cargo to compile as a library and link against, you can just give a path name. I don't know what happened to the quoting there, but you can just give a path name that's the path name of where your Cargo directory is for that library on your machine, and it will go compile that and include it in the project. So first thing I should point out is that we're now in the world of Rust 2018. We've been there for about a year. In Rust 2018, in Rust 2015 and earlier, there was this whole thing with extern crate declarations, and you'll see the book is full of extern crate declarations, which you were required to put in your Rust source in addition to providing a dependency in the cargo.toml to be able to get your library crates linked with your program. The extern crate declaration is not a thing anymore in Rust 2018, and you can just pretty much ignore places where it says extern crate blah and pretend you don't have to do that because you don't have to do that. So that's a source of confusion to a lot of people. The extern crate is really no longer a thing. You still can, it's code will still compile because it's backwards compatible, but you don't have to, most people aren't. Yeah.
That means the entire line is listed.
Yeah,
As long as
exactly.
it's in cargo.
Yeah, if you have a dependency in cargo.toml as of Rust 2018, you may now refer to names in that dependent crate without having to do anything special with your Rust source first. Namespaces are like in C++ or Nickel, they're colon separated instead of dot separated like in Java, which is probably a good idea, or Python. That using dot for both struct fields and module paths is kind of a source of occasional small bugs and friction. So we don't do that. We do the thing C++ decided to do, use colon. Which of course is Haskell and type what a mess. Anyway, so so a name like standard : IO : standard in should be read as the standard in function in the IO module of the standard crate, right? So we've got three different kinds of entities in that line. We've got a crate name, standard. Crates are also themselves sort of top-level modules. So the std module, which is part of the std crate, which every Rust program is linked against by cargo, whether you want it to be or not. That's almost true. I'm not lying quite. The IO module is the module that's responsible for IO, and standard in is a function within that module. Notice that I can also use declarations like I can in C++ or other languages. I can say use std.io.stdin and then call stdin without any qualifier because that function name has been brought into my namespace by the use declaration. So even though you don't have extern crate declarations anymore, you'll often find use declarations at the top to bring in stuff that you want to have brought in, so you don't have to type all these long path names for things. At that point, you can also type IO : stdin, which will let you make it clear which stdin we're talking about in the rare case that you don't know that. So you'll see all this mixture of path naming in the manual, in the Rust book, in our textbook. That's what this is all about. It's all pretty standard. I don't feel like I need to spend 10 minutes on it, but if you have questions about it, don't hesitate to ask. To be honest, the module system in Rust is one of the most common sources of friction and confusion for new Rust programmers. So please, do read about it, and then please do ask questions. It's real easy to get lost in stuff. They're not intuitive. So there's a directive called the mod directive. And if you want to use the mod directive, you can use it one of two ways. You can say mod some name and then put a block of code. And that block of code is now part of the new module. Mod foo, blah, some stuff. You now have a foo module, and it has some names in that module. That isn't the normal thing. The normal thing is that you just put a mod foo directive at the top of a file. That file is now the source file for a module named foo. You can kind of do this stuff anywhere. I can make a module inside a function that's a module that's usable only inside that function. Weird. but it's allowed, it's a thing you can do. It might even occasionally be vaguely useful. So which names in a module are visible? Well, they're the ones that you've marked with pub. The visibility by default for Rust modules is that names are not visible. You have to ask for them to be in the pub declaration. And you should be aware that for things like structs and enums, you can make the struct pub, but its field's private. You can make the struct private, its field's pub, although that's not useful in any way. You can make the everything pub, which would be the normal thing to do. You gotta watch out for those visibilities are separate. For library crates, that's an important qualification as boy. The compiler will whine at you about unused things if they're pub, because it assumes that somebody who's calling the library might call your thing, right? And so if you see a bunch of weird unused things warnings for your library functions, you might consider that you forgot to put pub in front and go fix it that way. Questions?
Yeah, is there a default, like, private?
The default is private, and the only other thing is pub. So everything's private unless you say it's pub. Everything you say is pub. That's it. Those are the only two choices. Yeah.
If you declare a public struct, do you have to individually declare every field public as well?
If you want to be public, yep. Yep, absolutely. So that's a thing to watch out for. Pretty often, because information hiding, you don't want to declare all the fields of a struct public. You want to keep them secret and only have this thing, have the code in the module that's operating on the struct, know what the fields are. But if you want the other thing, you can have that too. You just have to remember to stay public. I should be really clear about what pub means in terms of private to who, public to who, right? Pub means visible outside the crate you're compiling in. Names that within a given crate, you can always get at any name that's within that crate. There's no privacy there. The module system lets you control which names are visible in which scopes, so you might have to give a path or something like that. Why is this volt slide at this time? I don't know. It's a thing worth saying. So you've already seen Rust up, because I had everybody install their stuff using that. I'm not going to say any more about that right now. There's no reason. I mentioned earlier semantic version. The semantic versioning specification is this terrible document. Sorry, I have very strong opinions about semantic versioning, namely that it's mostly a lower food. But most of industry disagrees with me, so you should probably pay attention to most of industry. They're smarter than I am. You have this idea of a dotted decimal number, where the first thing, before the first dot, is the sort of major version number. This corresponds typically to a release or some other thing. And if the major version number ever changes, well, that means there's potentially arbitrary breaking changes to the API of the thing with that version. Then there's a major number, which if that ever changes, that's also potentially breaking changes to the thing. And then there's the minor version number, which just means something has changed. And it's more nuanced than I just described. You can go look at the semantic version specification if you care. Typically what Rust crates do is to start with version 0, and a lot of times never bump it beyond 0 for the, major version, the most major version, and then they bump the major version whenever they make it incompatible with the architecture. And you bump the minor version otherwise. This is supposed to improve stability. It's a lot of information to try to pack into a dotted decimal triple. I'm not sure. If you may have wondered what that cargo.lock file is that you've seen lying around. Cargo.lock contains the information about which versions of modules, of library crates and stuff, that Cargo is actually compiled from. So you can go through there and find out, well, if I said I want, version 2 or later of the food crate, you can go to cargo.lock and find out that it shows version 2.3.17. And further, you can make your builds reproducible in the sense that it's called the .lock file for a reason. If you build a library with a .lock file, it will use the versions that are in that .lock file. So whatever it's picked out for you, it won't move off that unless you ask it to by either removing the cargo.lock file or doing cargo updating. Make sense? Yeah. We've talked about doc comments before. It's worth talking about doc comments again. It turns out that sticking a little bit of extra stuff on the front of a comment gives you a doc comment that you can use Cargo Doc to format your documentation. I think we've talked about this before. The document stuff is formatted with Markdown as Markdown, so you can use all the Markdown prettiness to make your documentation come out pretty. And tests, so doc tests, which is what I meant to say in that bullet point, are a thing. We've talked about that before. And the test and config test directive and stuff let you actually control sort of how testing works. So, this is all stuff we've talked about before, but I thought it was worth mentioning again. Sort of part of learning to operate in the Rust ecosystem is learning how to operate all that extra machinery because people expect it. It's part of standard good practice Rust programming that you have doc comments in your library, that you have examples in your doc comments, that those examples be run as doc tests. But you also have other unit tests in your library. These are all things people expect to see. They expect to see